All right, it's about to look a little bit ridiculous. You don't have to understand what we're doing. What you need to gain an understanding of at the moment, just for the next minute or so, is the rearranging of the numbers. Know where the numbers go. Let's write in purple. It makes things fun. This is exponential form. This, that is the word log, L-O-G, is logarithmic form. I will explain this conceptually in just a moment, but you just need to know where the numbers go. Right now, that's all you need. Just hold this thought if you have questions. So considering where the numbers go, let's write the next one. Log, this is called the base down here. That is the base of your logarithm. What's a logarithm? I'll tell you later. The log base in this case would be 5 because this is the base and that's the base. I think it's worth pausing to label some things. This is the base of your logarithm. This is the base of your exponential equation. I just think that vocabulary is going to come in handy one day, just saying. And then the rearranging of the numbers, 25, and that is equal to 2 in this case. All right, let's do a couple more, and then I will explain conceptually what's really happening here. And you might just be able to fly right through this and say, I can put the numbers in the right place. Go for it. Have fun. Have a wonderful time. But I do want to make sure we understand not just the rearranging of the numbers, but a conceptual understanding. I'm having a hard time talking there. Conceptual understanding coming in about 20 seconds. All right, log base 7 of 1 equals 0. If you can rearrange the numbers, you can do a lot of the work. Now, this next one is not wrong. It's just not in the order we saw the first 4 problems in. Same is true with the next one also after that. That's 8 to the negative 1/3 equals 1/2. So it may help to rearrange things. All right, we're almost at the 20-second mark, I guess. I think we might be beyond the 20-second mark where I said the conceptual understanding is coming. Equals 3. Log base 8 of, don't be afraid to use fractions, 1/2 equals negative 1/3. And then the last one, if you're way ahead of me, then you might already have the answer written. But log base 10, I'm not going to write it, hold that thought, of 1,000 equals 3. Okay, so here's the deal in this case. There is an understood 10 right there. So if it is a 10, you don't have to write it. If you do write it, it is not wrong. It's just a little unnecessary. It's like dividing by 1 or putting a coefficient of 1 in front of something or saying, I'm going to add 0. Like, you don't need it. Okay, here goes. A logarithm is a way to figure out an exponent. If I handed you this, let's do that one right there. Log base 5 of 25, I am basically telling you, man, I really wish I knew what the exponent was that I would raise 5 to get 25. That was a little clunky and wordy, but let me just write down everything I just said. If I handed you this, log base 5 of 25, I want to know what it is. Huh? I don't know. Maybe it's 2. I know that. You know that. But what it's really saying is 5 to what power will give me 25? So this is simply rearranging, but in a minute, we're going to delve into some of them where you have to figure out, for example, on this first one, 4 to what power will give me 16? How many 4s would I need to multiply together to get a 16? Okay, it's not 4, by the way. It's not 4 times what? It's 4 to what power? Or in this case, understood 10 here, this is saying 10 to what power is going to give me 1,000? Okay, so like what would I raise? What would that exponent be? That's what a logarithm is doing. It's asking you, hey, can you tell me what that exponent would be that would make this thing work? That's what it is. Okay, let's move on and let's complete the same idea for the chart, only in reverse. We went from exponential form to logarithmic form. I think it's fairly self-explanatory that these are exponents and those are logarithms. Now we're going to start with logs and go to exponents. If you can rearrange the numbers, you'll be fine. So 2 to some power gives me 64. Well, they told me what that some power is. It's 6. So 2 to the 6 is 64. 2 times 2 times 2 times 2 times 2 times 2. 6 of them make 64. Okay? 8 to some power gives me 1. 8 to what power gives me 1? Not 8 times what? 8 to the 0 power gives me 1. Okay? What number am I pointing at? That'd be a 10, my friends. 10 to some power gives me 100. What power? Well, they told me it was 2. I could figure that one out, but still. Okay, 3 to some power gives me 81. It is a 4. You got to know where the numbers go. 20. My fault. 20 to the 2 gives me 400. And then last one, this one's fun. 25 to the 1/2. Whoa, you can have an exponent that's a fraction? Sure can. This is the same thing as a square root, by the way, and we'll talk about this more in the next video. But an exponent of 1/2 is a square root. That means I'm taking the square root of 25, which would be 5. So if you can rearrange from one to the other, you'll be okay. The big idea that you need from this video is, can I rearrange from exponent to logarithmic form? Just put the numbers in the right place. And also understanding when they hand you this, what are they asking? Oh, they're saying, 3 to what power gives me 81? And we'll delve into that right here.